All right, the objective for this lesson is that you'll be able to rotate objects a specified distance and direction. Let's see if my computer's going to be really slow today. So these notes were given in class on January 17th. This is from chapter 10, parts A and B. And so we said you need to be able to rotate objects a specified distance and direction. So by direction, we're going to say either clockwise or counterclockwise. Clockwise meaning in the direction of a clock, which is in this direction. Counterclockwise is in the opposite direction. And by distance, excuse me, we're going to measure the distance based upon degrees. So if you move an object from here to here, that's 90 degrees. Another 90 degrees would get you to 180, plus another 90 is 270, plus another 90 is 360 where you started. So each quadrant represents a 90-degree rotation. So if you go from quadrant 1 to quadrant 4, that's 90 degrees. Quadrant 4 to quadrant 3 is 90 degrees. And quadrant 3 to quadrant 2 is another 90 degrees. And counterclockwise is the same thing, just in the opposite direction. So let's look at an example of this. So if I rotate this object clockwise, there's a 90-degree rotation. If I keep going, now I'm at 180 degrees, which puts it upside down. Go another 90 degrees, that gets me to 270. And another 90 degrees gets me to 360, where I started. And the same thing in the opposite direction. It's a 90 degrees counterclockwise, 180 counterclockwise, 270, and 360 counterclockwise. Now, one thing you should notice is if I go 180 degrees clockwise, so 90, 180, and make the object upside down, that's the same thing as going 180 in a counterclockwise direction, 90, 180. So going 180 degrees, it doesn't matter which direction I go, I still end up in the same place. Okay, so this is what we're going to be doing today. We're going to be rotating objects either in a clockwise direction or a counterclockwise. So let's look at an example. So we have this triangle, ABC. In this table, I have the coordinates of the points. So point A is at 0, 3, B is at 2, 0, C is at 0, 0. I want to rotate this 180 degrees counterclockwise, and I want to write the coordinates here. So we're going to take this object, rotate it counterclockwise 180 degrees, and then we're going to draw the new object and write the new coordinates here. Now, some of you are able to look at this and visualize what the new shape is going to look like. If you're unable to do that, there's a trick. I'm not good at visualizing these, so I actually use this trick. Draw this on a piece of paper, piece of graph paper, and then physically turn your paper. So we're going counterclockwise. If I turn my paper to here, that's 90 degrees counterclockwise. Keep going. Now I'm at 180 degrees counterclockwise. So I took my paper. Here's where I started. My computer's really goofy. I turned 180 degrees counterclockwise. And now I can see what the new position looks like. So what I do now is I look at these new positions and I write down the coordinates of those. Now, you need to be careful because since I rotated the graph, now the numbers are not correct. This shows these x values being negative. They're actually positive. These are negative. These y values should be positive, and these y values are negative. So the numbers on the grid no longer are correct because I just turned the grid upside down. So you've got to think of what they should be. So let's look at the coordinates for point A. This is going to be my new A when I draw it down here. It's at 0, negative 3. 0, negative 3. My new B is here. That's at negative 2. Again, it says positive 2 here, but that's not correct. Negative values are over here. So I walk negative 2, I climb 0, so that's at negative 2, 0. And the last point, 0, 0, or C, is still at 0, 0. So now, take your paper and turn it back the way it should be. I'm going to And again, I'm physically doing this with a piece of paper. I know I'm doing it with my computer, but you can do this with a physical piece of paper if I can get this to cooperate. And now just graph these points. So we said A prime is at 0, -3. So that's here. That's A prime. B prime is at -2, 0. So that's here. And C prime is at 0, 0 still. And now I connect the dots. Let me change the color of the line. Change it to blue. And I'm going to reconnect the dots. And so now I have the rotation of triangle ABC 180 degrees counterclockwise. So we took ABC and we rotated it this way 180 degrees. All right, so if you didn't catch that, back it up and see what I did again. Follow it through. It's really very simple. I turned my paper 180 degrees counterclockwise. That shows me where my object should end up. I write the coordinates of it after I've turned it upside down. I put down those coordinates, and I put my paper back the way it was originally, and I graph those coordinates. So let's look at another example. So we have this triangle ABC, and we're going to rotate it 180 degrees clockwise. Now this one is much more difficult to visualize in your head. Again, if you can visualize it, that's great. Me, I'm not so good at that. So I'm going to use my method of rotating the paper. That to go away. So again, you draw this on a graph. Physically take your graph paper and turn it 180 degrees clockwise. So there's 90 degrees. There's 180 degrees. Again, my computer is being really goofy. So now here's where I want the object to end up. I just turned my paper 180 degrees, so basically turn my paper upside down. I'm going to write down these new coordinates of ABC. So A, again, these numbers are not correct now. These should be positives. A is at 1, 2, 3, 4, -2. So A is at 4, -2. B, or B prime, is going to be at 2, -4. And C is going to be at 1, -1. So let's turn my paper back in the proper direction. So I'm going to turn my paper back around. And now I'm going to graph those points. 4, -2. B is at 2, -4. And C is at 1, -1. Let's connect the dots now. Change my color again. I should have labeled these points as I wrote them. A was at 4, -2, so that's my A prime. B prime is at 2, -4, and C prime is at 1, -1. So that's this object rotated 180 degrees clockwise. Okay, so hopefully everyone understands the method of turning your paper around. If you're able to do this without turning your paper, that's great. And keep in mind, this is something you could do on a test. As long as you're able to physically turn your paper, you could do this on a test. Let's look at our last example. So this is an example where we don't have a grid. We just have a letter, in this case the letter F. Could be a shape, it could be an object, a picture, anything. Let me copy this. Put this here. So again, it says rotate the letter F 270 degrees counterclockwise. So you can physically turn your paper 270 degrees and it'll show you the new position. So if I turn my paper 90 degrees, I get that. Turn my paper 180, I get that. 270, I get that. And then I just have to draw that figure. Now, maybe you noticed that going 270 degrees counterclockwise, so I went 270 counterclockwise, is really the same thing as just going 90 degrees clockwise. So you can go 90 degrees clockwise and get to the same place as going 270 counterclockwise. All right, so that's all there is for this lesson. If you have any questions, back it up and look at it again, or you can email me or ask me in class. So, this is Mr. Bywater, out.